Okay, so the question that you had asked is if something has a gravitational force of negative 32 meters per second, which is actually written like this, meters over second squared, and they throw it straight up in the air so that it can reach a height of 550 meters, what would its initial velocity be? Now, these types of problems are known as projectile problems. You throw something in the air, and due to gravity, it comes right back down. It makes a parabolic shape, which you see here. So this person, well drawn, as you can see, threw something in the air, it went up, then it comes straight back down. It's actually going to be, even if they throw it straight up in the air, it comes right back down again. It's even if it's a directly straight line, it still goes up and it comes back down in a parabolic way. Now, all parabolic functions and all projectiles use actually a remarkably similar formula. We call it the projectile formula, or placement, or sometimes distance. But this is the formula right here. The negative 16 represents the gravitational force, which is related to 32. We'll get to that in a second. So it's always going to be negative 16 variable squared. In this case, we're using t for time, which is always in seconds. So when it says t for time, we mean how many seconds are passing. There's always a v sub 0, and that's a fancy way of just saying the initial velocity. So what was the velocity that it started at? That's what this represents. T plus h sub 0, which is also a fancy word for what was the initial height. Those sub-zeros refer to, when time is at 0, what did it start as? So what was its, at the time of 0, what was its velocity? Time of 0, what is its height? Okay? And this is the formula. You should definitely, you hopefully have had experience with this formula in pre-calculus, because in pre-calculus they actually deal with this a lot. So hopefully you had that, and this will be familiar to you. This right here is one of the major places where physics and calculus merge. So now let's take this idea and let's go on to something we've talked about a bunch of times. When you have distance and you take the derivative of distance, you then get something for velocity. What do I mean by that? So if this is a ball that is thrown up, say 550 meters, and then it comes back down, if you take the derivative of the formula for this equation, which is actually this formula here, you will get the formula for the velocity at each point. If you then take the derivative of the velocity formula, you'll then get the acceleration at each point. Now, at this point, we know what the acceleration is. We were told it's negative 32 meters per second. So rather than starting with the distance formula and the velocity, I'm going to show you how they're all related, and I'm going to show you how to interact with all of them. Let's start with the acceleration. Cover all these up. You were told that the acceleration is negative 32. If you anti-derive that, you will get negative 32t plus a constant. In this case, the constant that we're talking about happens to be the initial velocity. Okay? So rather than negative 32t plus c, I'm just going to replace it with v sub 0. It's still a constant. It's the constant of velocity that we're talking about. You'll see why. I could use it as c. It's not going to change the formula. It's going to still be a constant. I'm just conveniently using v sub 0 instead of the letter c. If you then anti-derive this, negative 32t, you then actually get, well, t becomes t squared. We know that. So that 2 in the t squared times what gets you negative 32? What gets you negative 16? So the antiderivative of negative 32t becomes negative 16t squared. The antiderivative of v, a constant, becomes constant with a variable next to it. And then there's nothing here, so of course you have to add a constant to that. So that's how they actually get this formula. And they're all related to each other, because this one you derive that, you get this. This you derive that, you get this. The antiderivative of this, of the velocity, is acceleration. The antiderivative of distance is velocity, and go up and down and up and down. It's the same thing. All right. So how do we then take all of this information and solve it? Well, the two ways you can do that. Well, there's really one way. First of all, we take this formula, and we know that the height and distance that we want to get to is 550 feet. Let me write that out. 550 meters, I should say, not feet, is equal to negative 16t squared plus v sub 0 t plus h sub 0. So we know that we want this formula to get to 550. We also know that our starting point is actually on the ground. See, when we start, we're actually on the ground. So this we can already assume already is 0. Again, we're assuming that because we're on the ground. So we don't even have to worry about that. So that's gone. Don't even worry about it. So really the only thing we have to worry about is 550 at a certain amount of seconds we'll have an initial velocity. So already we have two variables here to solve. The time we can solve not with this equation, but with the other equation. Okay, now how do we do that? Velocity is the derivative of distance, right? Well, at any point here, is the derivative a constant number that we know? Yes. At this point right here, the tangent is going to be horizontal, therefore it'll be 0. The slope of it will be 0. If this distance formula is this graph right here, then at this point, its derivative will be 0. And since the distance formula, the derivative is the velocity, we know that at that point, the velocity will be equal to 0. So we can play with that. So I rewrote it here, and I set it to 0. Now we just solve for t. So we add 32t to both sides, then divide by 32, and you get t is equal to v sub 0 over 32. That was a little fast, but basically, again, you write out this formula, you equal it to 0, because we know that the distance equals the horizontal slope of the distance at its max will be 0, therefore its derivative will be 0 at that point. And then we can use that to solve for t. Take this value and plug it back in to this. So you get, I rewrote it over here. So 550 is equal to negative, oh, I wrote c for constant. I should have wrote v sub 0. You know what, actually, v sub 0, 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 this is going to look ugly. V sub 0, v sub 0, v sub 0. Okay. So, we plugged it back in, because we did solve before that t is equal to v sub 0 over 32. So now whenever there is a t, we write v sub 0 over 32. Square that, actually, can I show them? Mm-hmm. Yara just finished her time, so hi, there you go.
Hi, Iris.
So I'm just waving goodbye to her. Okay, so if we take v sub 0 and we square it, we end up getting, and multiply by negative 16, that just simplifies out to v sub 0 squared over 64. V sub 0 times t is the same thing as v sub 0 times v sub 0 over 32, which ends up being v sub 0 squared over 32. Since h is worth 0 anyways, or h sub 0 is worth 0 anyways, we're just going to forget it. Because now we have 550 is v sub 0 squared over 64 plus v sub 0 squared over 32. 32 and 64 are half of each other. So multiply this side by 2 over 2, and you get 2 v sub 0 squared over 64. Now the denominators are the same. So what we can do, don't forget, this was a negative, so this is a negative, so this is a negative, so that's a negative. Now we can combine them into one fraction. Negative v sub 0 squared plus 2 v sub 0 squared over 64. With one negative v sub 0, negative, and two positives, they combine together to make one positive. V sub 0 squared over 64 equals 550. Multiply both sides by 550 and you get 35,200 is equal to v sub 0 squared square root both sides, and you get 187.62 approximately is equal to V sub 0. Okay?